Hi, I'm Sean Gannon, and this is Minute Math. And today we're learning about understanding functions, domain, and range. In this video, we're going to talk about the domain and range of a function. We're going to talk about the relation of a function. We're going to talk about the domain in real life. We're going to write a function and its domain. And lastly, we're going to talk about domain restrictions. And so, when you're ready, let's get started. We are given the relation here, the set of points 1, 2, 2, 4, 3, 6, and 4, 8. Find the domain and range, and then what we want to determine, is it a function? Let's first write the domain here. Okay, so the domain here are going to be the set of points that are the x values of each coordinate point. That's our input values. So x here, first one's going to be a 1, then 2 right here. Right, put a little green dot, we can see it there. 3 and 4. And so our domain is 1, 2, 3, and 4. Now what about our range? Well, if the domain is the x values, the range is going to be our y values of each coordinate point. So the set of values of 2, 4, 6, and 8. And so we have our domain and range here, and now we have to determine, is it a function? Well, if you look at here, no x values actually repeat. So that kind of gives us a clue. Since we have no repetition in any of our x values, we know it's going to be a function here. But if we did have repetition here, we want to make sure that its paired up range value, okay, is different. Then that would mean we don't have a function. Okay, so if we have the same x values, but we have two different y values, that is not a function. But if it was the same y values, then it would still be the same point, and so it is a function. So here we have all different x values, so we would say, yes, it is a function. And so now we learned about talking about the domain and range of a relation here and determined if it was a function. Is this a function? We have this set of points here, 1, 3, 1, 4, and 1, 5. Is it a function? The answer is no, it is not a function. But why? Let's look at our input. We have input of 1, 1, and 1. They're all the same 1. But 1 goes to a 3, it goes to a 4, it's mapped to that, and it's mapped to a 5. So this input value of 1, the domain here, has 3 different output values that it's mapped to, okay? And since it's not just mapped to one value, it's mapped to more than one values, in this case 3, then we would say, no, this is not a function. A company makes up to 100 items a day. What is the domain of the function c of x that gives the cost to make x items? Okay, we're not asked here to come up with our function here. We're just trying to find the domain here of x items here. How many items can we actually make in a day? So they tell us here, our clue is our company makes up to 100 items a day. So we can go up to 100. 100 is going to be the max right here. So we can equal 100 items in a day, and x can be that value or any value less than 100 within reason. Right? And what is within reason? Well, the company can make 0 items in a day, right? That's the lowest that it can make. It can't make negative items, right? We can't have negative items made. So our lowest value is going to be 0, and so up to 100 would include 0, so we have equal sign there and a less than sign. And so our domain here would be 0, less than or equal to including x right there, and less than or equal to including 100, okay? So we have 0 to 100 here, up to 100 items, and the practicality of this, again, we can't have negative items produced, okay? So our domain here is from 0 to 100, including 0 and 100. A person walks 3 meters per minute. Write a function for distance over time and state the domain. So let's write our function first, okay? So our function here, our distance relationship to time, is equal to, well, they tell us 3 meters per minute, so we can put a 3 here, and we're multiplying that by how many minutes the person's walking, by t, time. Time is in minutes here. So our function here would be d of t is equal to 3 times t. What about our domain? Okay. Well, our domain is referring to our t values. What are the possible t values in this function? Well, the person can walk for 0 minutes, right? We can walk for 0 minutes. And so we have 0 here as being less than or equal to t, which can go on forever. Anything bigger, they can walk hypothetically forever, infinitely many minutes. So our domain here is 0 is less than or equal to t, or if you want to write it this way, you can say t is greater than or equal to 0 to have the t value first. So our time for walking can be 0 minutes as well as anywhere past that, greater than. But we can't have negative minutes of walking. So again, our function here, d of t, is equal to 3 times t, and our domain is 0 is less than or equal to t. Describe the domain of f of x is equal to 5 over x. This one's a little tricky here. What is our domain here? We got to describe that. Well, what values for x can we plug in? That's really our domain that we can put into our equation and it produces something. And the reality here is anything except for one number specifically. We can put 100 in for x, 1 in for x, negative 5,000, negative 1.03457256791. One value that we cannot plug in is 0. X here cannot equal 0 because we cannot divide by 0. If the 0 would in, it'd be undefined. 5 divided by 0, we can't do that. CDT, as I like to call it. And so our domain here would be all real numbers except 0. So our domain here is all real numbers except 0. Let's recap what we've covered. In this video, we talked about the domain and range of a function. We talked about if a function is a relation. What's a domain in real life? We wrote a function and its domain, and we talked about domain restrictions. I now leave you here with a bonus problem. Find the domain of the function f of x is equal to the square root of x minus 2. My hint for you here is, what can you not take the square root of? I hope you learned something here about understanding functions, domain, and range. And as always, thanks for watching.